Good morning, students. I welcome you to my video lectures on signals and systems. Now, I have started Z transforms, and in this class, I will show that Z transforms is extension of Laplace transforms. There is relationship between Z transforms and Laplace transforms. First, as you know that in nature we have continuous time signals. So how to get a discrete signal? Sampling. So only by sampling one can generate a discrete signal. So here I have shown a continuous time which exists even for positive values as well as for negative values of t. That is on this side as well as on this side. And this continuous time signal is sampled at the end of every t seconds, capital T, period. That is called as period. Every t seconds it is sampled. And here we are getting what are called as discrete signals. See, first here 0, t, 2t. That means this is 1t, this is 1t, this is 2t, 3t, etc. So even for negative values of t, minus 1t, minus 2t, etc. Now, to show that Z transform is an extension of Laplace transform and continuing with t. Normally we don't write t, but to establish a relationship between the two transforms, I am considering t. Now, during a convolution sum, you know how to express a discrete signal. How to express a discrete signal? This is x of nt. This x of nt now is x of 0. So this exists at 0t plus x of 1. This exists at 1t. Next x of 2. This exists at 2t. Is it not? Etc. etc. Next x of minus 1 that exists at minus 1t. X of minus 2 that exists at minus 2t. Is it not? So in this way one can write the discrete signal. Now you know at the time of studying convolution sum how to express a discrete signal in terms of impulses and shifted impulses. You know. Now I will use that. Now one can write x of nt as now summation n equal to minus infinity to plus infinity into x of nt and delta of t minus nt. Delta of t minus nt is what is called as shifted. For example, n equal to 0, that means unshifted. Next, n equal to 1, delta of t minus t, that is shifted to the right by 1 unit. So this is what is called as shifted impulses. So one can write the discrete signal as x of nt is equal to summation n equal to minus infinity to plus infinity x of nt delta of t minus nt. Now for this you take Laplace transform. Laplace transform of x of nt. Laplace transform of x of nt. If you take Laplace transform, now Laplace transform, right hand side, Laplace transform, under that summation minus infinity to plus infinity x of nt delta of t minus nt. Now x of nt is a constant. See here, height. This is x of 0, this is x of 1, this is x of 2, this is x of minus 1. They are all, x of nt are all constants. Therefore, it becomes summation n equal to minus infinity to plus infinity x of nt and Laplace transform of delta of t minus nt. I will remind you from Laplace transform. Laplace transform of an impulse function is unity. Laplace transform of a delta function is unity. It is always a student friendly function. Laplace transform of a delta function is a unit impulse function is unity. Laplace transform z transform of impulse function is unity. Fourier transform of delta function is also unity. So L of delta of t is 1. What about Laplace transform of delta of t minus a? Delta of t minus a is e power minus as. E power minus as. You have to very well remember this formula. L of delta of t minus a is e power minus as. Now here one can write the Laplace transform as. Now here I will write the Laplace transform. The Laplace transform is the Laplace transform of x of nt is equal to summation n equal to minus infinity to plus infinity x of nt. Now Laplace transform of delta of t minus nt, very much similar to this expression. One can write this as e power. Laplace transform of a shifted impulse function is L, very much similar to this, e power minus n t s, where s is known as complex frequency of Laplace transforms. Now this is the after taking Laplace transform for shifted impulse functions. Now in this one can rewrite this as summation n equal to minus infinity to plus infinity, n equal to minus infinity to plus infinity x of nt into, one can write this as e power ts to the power of minus n. One can write this as e power ts to the power of minus n. As you know that a to the power of m, n is equal to a mn. a m a n. Very much similar to this, x of nt e power ts minus n. Now I will call this as e power ts as z. I will call this is z is also a complex number, e power ts as z. Then the summation becomes n equal to minus infinity to plus infinity x of nt z to the power of minus n, z, where e power ts is z. So this is what is called as definition of z transform. So this is what is called as definition of z transform. So the function here in this example, function is existing for negative values of t as well as for positive values of t. Even if the function exists for positive values of t, then it becomes from 0 to infinity. That's all. Now this is what is called as Laplace, not Laplace, z transform, that is called as x of z. So what is x of z? X of z, that is z transform of a time function, is given by x of z equal to summation n equal to minus infinity to plus infinity x of, normally we don't write t, simply write x of n z to the power of minus n. This is what is called as definition of z transform. Now from the definition of z transform, manipulation, so this expression was possible because of this simplification, e power ts equal to z. To establish relationship between z and s of Laplace transform, z of z transforms, take logarithms on both sides. Taking logarithms on both sides, so here we have e power ts equal to z. Take logarithms on both sides. Ln e power ts equal to ln z. Ln z, or what is ln of e power ts? Ln of e power ts is t, here I will write ln e power ts. Now I will continue. E power ts equal to z. Take logarithms on both sides. Ln e power ts equal to ln z. Ln natural logarithms of an exponential number is ts ln e equal to ln z. Ln e is 1. Therefore, ts is equal to ln z. Therefore, the relationship between s and z is s is equal to 1 by t ln z. This is relationship. Yes, relationship between s and z. S equal to 1 by t ln z. Therefore, in Laplace transform, we call it as x of s. In z transform, we call it as x of z. So what is x of z? X of z is same as x of s, substituting s equal to 1 by t ln z. So student in this class must remember this relationship between z transforms and Laplace transforms. So z transform is extension of Laplace transforms, and the relationship between z transform and Laplace transform is this e power ts equal to z, or s equal to 1 by t ln z. In the next class, I will take simple functions, and we shall find z transforms. Thank you.